Finding the slope of a line, physics lecture. Let's take the points 3, 5, and 6, 2 and plot them on a coordinate plane. A lot of people are taught this with a formula. There's nothing wrong with that. But I think if we were a little smarter about it, we might be able to understand it a little more clearly. Now, when I teach this, I like to tell people to just look at the points and just, figure it out from there. So this point is 6, 2. And this point is 3, 5. This is a little bit easier to do if you're on graph paper. But it shouldn't be too bad here either. So when we want to figure out the slope, and actually whenever we want to mess with 2 points, generally want to draw a triangle with a right angle. And the slope is the change in y over the change in x. That is a little delta. And it means change. So how much did the y change? Well, let's see. We're up at 5. And we go down to 2. 1, 2, 3. So it went down 3 from here to here. And here it went over 3. So the slope is -1. And -1 just means it goes down to the right, because the negative slope goes down to the right. Positive slope goes up to the right. And 1 just means it's 45 degrees. It's pretty steep. And that's really it. A lot of people freak out about slope. It's just, you look at a hill. Is it Mount Everest where it goes almost straight up, or is it a nice flat little meadow that just barely rises as you go along? So that's all slope is. All right? Slope is -1 in this case. And let's take a look at this. We ended up saying, well, actually, we'll do it again without going into all the details, that it goes down 3 and over 3. And the slope equals -3 over 3. Now, what if the x-axis is time? So we fill this out with units, seconds, and the y-axis is distance, meters. We'd get a slope of -1 meters per second, which is a velocity, a speed. So when we look at a graph, don't just look at the numbers, look at the units, the y units over the x units. So we'd have to have something down here about time, seconds. We'd have to have something up here about distance, in meters. So we know what we're talking about here. But the slope is that simple. Y over x, meters per second. Oh, we're going to get a velocity out of this. So we'll have a few examples like that. Now look at this. Meters per second. So we're calculating velocities. So we might even want to put velocities in there. And from A to B, it goes up from 0 to 10. Not a very well drawn graph. Yeah, it does look like 10. So it looks like it's going up 10 and over looks like 5. Which I don't know why I'm erasing these. I should leave these in. And we know that's meters per second. So the slope there is 2 meters per second. So if this is a person on a bicycle or something, they're going 2 meters per second. What's their slope here? From B to C. Well, they go 4 seconds, but they don't go up and down at all. So they go 0 meters. 0 divided by 4, if you're not sure, put in your calculator, 0 meters per second. If they're on their bike and they're going 0 meters per second, that means they stopped. This is somebody who biked out for 5 seconds, stopped, realized they forgot their watch or something, turned around, and came back because this is a negative slope. This is approximately 5. Again, not a very well drawn graph. It goes from 10 to 5. So that's negative 5 meters in 1, 2, 3. 3 seconds. So on the way back, it's negative 1.7 meters per second. He's not in a rush. He's ticked off about forgetting his watch, or she, and just kind of drives home a little bit, bikes home a little bit slower. That's analyzing a graph. Just don't forget your slope is y over x. Don't forget your units. You're pretty much good to go. Now here we have velocity versus time. So what's the slope represent? And what is the slope? We have to look at it first. Start at 1. 1, 2, 3, 4. So the slope is 4 positive. 1, 2, 3, 4, 5, 6, 7, 8. Watch your scale. There's 2 between them. Over 8. And now we have meters per second. That's the velocity. Over time in seconds. Slope is 0.5 meters per second squared. Hopefully you remember that's acceleration. So you have to look at your units, know what you're talking about. This is a car that's steadily accelerating at 0.5 meters per second squared. Not that big a deal. Probably at a traffic light and they're just getting up to speed. Now, if the car was moving at a constant speed would be velocity equals 0. No, pardon me. Velocity does not equal 0. It's moving. But the acceleration does equal 0 meters per second squared. It's at a constant speed. It's not accelerating or slowing. So that graph would be a flat line. Now, what would it look like if his car was going backwards? Well, once the car is moving at a steady speed, it would still be a flat line. But let's say it stopped and decided to go backwards. So your original graph looks like this. It's accelerating, and then it gets a constant speed, and then it brakes. So I don't even think that slowing down would probably be a better way to put it. A lot of people get confused right now because I've flipped back and forth between meters per second and meters per second per second. This is if we're talking about a velocity over here. And this is if we're talking about time. So this means the car is slowing down. Play with it. See where it takes you. Don't forget your units when you're calculating slope. Don't just use numbers. That's what we do in math class, and it's terrible. Use units. Try some problems. Good luck.